My name is Strugglesby here. So today we are going to be going over our acid and base nomenclature rules. Hopefully a lot of y'all have already learned this in the past in your previous chemistry course, but if you have not, this is a great place to start, kind of get you moving in the right direction. Now I would highly suggest that if you have not already watched the ionic compounds video and ionic nomenclature video, that you go ahead and go watch that video because it is going to really help you with this in terms of getting you started with your acid and base nomenclature rules. Okay, all right, so let's go ahead and get started. So for your acid and base nomenclature, we're going to actually start with bases. Well, we're going to start with bases because bases are basically, ionic compounds in terms of how we name them. All right, now they are all ionic compounds. All of these that we're working with, acids or bases, those are ionic compounds. But with a base, we actually name it and write its formula just like we would a regular ionic compound. Okay, there's nothing special about it. Okay, so you're just going to follow your ionic compound rules. So follow your ionic compound rules. Okay, now with acids, on the other hand, they actually have a set of rules that you have to follow. Okay, there's three simple rules that you have to follow. Okay, now this right here is kind of a description of those rules and what you're looking for when you're talking about it. With an acid, you need to know first off if it is a binary or ternary acid. Okay, well, how do I know what a binary or ternary acid is? Well, a binary acid is basically an acid that's got a hydrogen and one other element attached to it, one other anion attached to it. Because again, remember, these are ionic compounds, right? So for binary, we've got hydrogen attached to one other element. Okay, whereas on the other hand, a ternary, again, is kind of what it sounds like, because binary is like a bicycle, right? It's got two wheels on it. Binary is, it's got two elements attached to it. One of them is hydrogen. So ternary is more than two, okay? So I've got a hydrogen attached to a X, Y, Z, and so on. Right, so it's a hydrogen attached to those things. Now, when you write these things with an acid, you're always going to be writing that hydrogen first. Okay. All right. So now that we know what a binary acid is versus what a ternary acid is, let's actually take a look at how we use that. Okay. I'm actually going to look at this table instead of all this words because I feel like me reading it to you isn't the best way for you to learn this. Okay. So if I'm talking about a binary acid, I'm talking about an acid that's, again, got two elements, one of which has to be hydrogen, the other of which has to be some other random element, okay? If it's ternary, again, one of those elements has to be hydrogen, and then we've got multiple elements that are attached to that, okay? And this is basically a polyatomic ion. Okay, so you're going to be looking for a hydrogen attached to a polyatomic ion. And when you do that, you're actually going to have a ternary acid. Okay, so what do I do with this? How do I use this? Okay, well, with binary, there's some things that you need to know. First off, if I immediately recognize that it's binary, then that tells me immediately that when I name it, I have to start my name with hydro. Okay, so I start the name with hydro. Hydro is the first signifier that this is an acid that only has two elements, one of which, again, is hydrogen. The next part when we're naming a binary acid is we're going to name that anion. So the anion is, again, that negatively charged ion that is attached to the hydrogen. Okay, so the negatively charged ion that is attached to the hydrogen. Now, just like with ionic, we're going to change the ending. With ionic, you change the ending to "ide," right? Anytime we're talking about an ionic compound, you change its ending to "ide" if it's the anion. Acids, though, we change the ending to "ic." Okay, so I've got my anion, and I change its ending to "ic." So how does that look? Okay, well, if I've got a hydrogen, and it's attached to a chlorine, first off, I know this is binary, right? There's a hydrogen, one element, and a chlorine, another element. Two elements, binary, okay? So since there's two elements and it's binary, I know that I'm going to follow my binary naming rules. So I start with hydro, because all binary acids start with a hydro. Then I'm going to name my anion. So my anion here is chlorine, okay? But remember, with a acid, we're going to change the ending to ic. So this is hydrochlor, and we change that ene to ic. So this is hydrochloric. Well, hydrochloric what? This is hydrochloric acid, okay? So acid is one of those things that you add to the end of an acid to signify that it is an acid, right? Kind of seems superfluous, kind of seems like you shouldn't have to do that, but you do, right? So that's what we do. So now that we know that we've got that acid on the end, we know that this is one, binary. Why? Because it starts with hydro. Two, I know that this is a chlorine that is attached to, and I change the ending to ic because it is an acid, specifically a binary acid, okay? Instead of changing it to ide. Now, ternary, on the other hand, it's got two rules you have to follow. Okay, so this is where those three rules came in. First off, your first rule is that if it's binary, you do one thing. Specifically, add the prefix hydro to the beginning and change the ending to ic. Ternary has two different rules you have to follow. Well, the first rule is if I end in ate, I change to ic. Okay? The second rule is if I end in ite, I change it to us. Now, what are we talking about? Well, we're talking about the anion, okay? We do not use hydro at the beginning of any ternary acid. Why? Because that would get things very, very confusing very, very quickly, okay? For instance, chlorine there with that hydrochloric acid, there's some polyatomic ions that have chlorine in them. So if I added hydro and in the polyatomic ion, the anion, ended in ate, then it would still say hydrochloric acid. Well, they're two different things, right? One's got the chlorine attached to just the hydrogen, and the other's got that polyatomic ion attached to the hydrogen, okay? So we've got two different things, so we have to make sure that we're keeping that in mind while we're looking through those, okay? So ternary, three or more elements, one of which is going to be hydrogen. Ending changes from ate to ic. And what do you mean? What do I mean when I'm talking about ate? Well, if I've got CO3, that is carbonate. Okay, so this is an ate. So I would change that ate to ic if it is bonded with a hydrogen at the beginning. Okay, so anytime I've got a hydrogen attached to a polyatomic ion, I'm going to look at the end of that polyatomic ion and I'm going to try to decide, is it ate or is it ic? If it's ate, I change it to ate or ite, sorry. If it's ate, I change it to ic, and if it's ite, I change it to us. Ate changes to ic, ite changes to us. So here is a little saying that I always have used to help me remember ate to ic and ite to us. So I went ahead and wrote it down there at the bottom. So my saying is, last night, all of us ate something icky. Last night, all of us ate something icky. What that tells me is that ite goes to us and ate goes to ic. That helps me remember my ternary acids and how I need to change that ending. So let's actually go ahead and do some practice problems. So here, give the correct name for the following. Here I've got HBr. HBr. Element 1, element 2. I've got two elements, so that immediately tells me that this is binary. All right, so this is binary. Well, since it's binary, I know that anytime I name a binary acid, I always start with hydro. Okay, well, what comes next? Bromine. We write our anion down. So this would be hydrobromine. But when I have an acid, I change the ending of that anion to ic. So instead of being hydrobromine, it's going to be hydrobromic. And then it's an acid, so we write acid. So hydrobromic acid. Next, number 2, I've got HiO3. I've got element 1, element 2, element 3. I've got 3 elements there. So that tells me immediately that that is a ternary acid. How do I know it's an acid? Well, it starts with hydrogen, so it's going to be an acid. So I've got 1, 2, 3 elements there. Again, that's going to tell me that that's a ternary acid. So how do I do this? Well, I start with my anion. Well, this anion is what? Okay, well, you need to think back on your polyatomic ion names. IO3 is iodate. Okay, so iodate. Well, we would take this, we would change our ending to ick, right? Because last night all of us ate something icky. So 8 goes to ick. So this would be iotic acid. Okay? All right. So I want y'all to take the rest of these, go ahead and try some practice. I will post a key for y'all to do. And then we are going to go ahead and move on. So if you want to work these right now, go ahead and pause. But we're going to go ahead and move on to the next portion. Okay. So now we're actually going to take the names and convert them in the other direction. So we're going to go from the name to the formula now instead of from the formula to the name. So how do I do this? Well, I look at the name. First off, on this name, I have hydroiodic acid. This starts with hydro. Well, hydro, again, remember, tells me that this is a binary acid. Okay, so since it's a binary acid, I know that it's hydrogen attached to one other element. Well, now I have to figure out what other element it is. Well, it's iodic. Iodic is iodine, right? So iodine, its symbol is I. So I have hydrogen, I have iodine. The last thing I need to do is double check my formula, make sure those charges that they would produce would cancel out. Hydrogen produces a +1 charge, iodine produces a -1 charge. So we've got a +1 and a -1, they're going to cancel out. Okay, since they cancel out, this would be our final formula. Do one more, then I'm going to leave the rest of it for y'all to do some practice. So I have chloric acid here. So chloric acid, again, it says acid, so I'm going to start with hydrogen, not hydro, hydrogen. And now I need to figure out what's going on here. Well, I know this is a ternary acid because it did not start with hydro. So since it didn't start with hydro, it is ternary, which means there's going to be at least 2 other elements there. Well, this is chloric. So how do I know what other elements were there? Well, if we remember, we changed what to ick? Well, we changed 8 to ick. So if I'm going in the other direction, I'm going to take that ick and change it back to 8. So this is chlorate. Okay? Well, what was chlorate? ClO3. So I have hydrogen, chlorine, and 3 oxygen there. So what do I do with that? Well, now I need to double check my charges. The polyatomic ion chlorate has a -1 charge, and hydrogen has a +1 charge. They're going to cancel out. That would be the practice for you there. So I'm going to leave y'all the rest of this to do. Please go through and practice what you need to practice. I'll post the key, and you let me know what you need help with. All right. Bye, y'all.